All right, hi class. Sorry that I'm not here today, but in place of me, I've created this video. So in this video, I want to talk to you guys about solving absolute value equations with extraneous solutions. So that word extraneous in this situation basically just means an extra solution. Look at that base word, extra. It's an extra solution. It's kind of like an imposter. It's a solution that you find, but when you actually plug it back into check, is not actually a solution. So the key to solving equations with extraneous solutions is to check your answers. Once you find your solutions, plug them back in for x and check to see if it's actually an answer to the equation. Does it make the equation true? So let's take a look at this first example. In order to solve any absolute value equation, you need to set up two equations. The first, you set up just as normal, 5x plus 2 equals 2x. The second equation you set up has the inside of the absolute value symbol equal to the opposite of the thing on the other side. So in this case, it'll be negative 2x. And then you go ahead and solve each equation for x. So I'm going to subtract 5x from both sides here. And I'm going to get 2 is equal to negative 3x. Divide both sides by negative 3. And I get my first solution is that x could be negative 2/3. The second equation, I'm going to subtract 5x from both sides and get 2 equals negative 7x, and divide both sides by negative 7 to get x equals negative 2/7. So, to check and see if these are in fact solutions to this equation, I need to plug them in to the equation itself. So I'm going to take the absolute value of 5x plus 2 is equal to 2x and check for each solution. So I'm going to check x equals negative 2/3. And I'm going to also check x equals negative 2/7. So when I plug in negative 2/3, I get 5 times negative 2/3 plus 2 is equal to 2 times negative 2/3. When I simplify the inside of the absolute value symbol, I get negative 10/3 plus 6/3 is equal to negative 4/3. The absolute value of negative 4/3 is not equal to negative 4/3. So x equals negative 2/3 is not an actual solution. It's an imposter. It appears to be a solution when you solve, but when you plug it in, you do not get a true statement. Now let's check negative 2/7. So I plug in negative 2/7 for x. Run out of space over here. Squeeze that in. And on the inside of the absolute value bar, I get negative 10/7 plus 2 is equal to negative 4/7. You're going to see again here that negative 4/7, the absolute value of it, is not equal to negative 4/7. It's just not possible to take the absolute value of something and have it equal to a negative value. So the real solution to this equation is that it has no solutions, because the two solutions we found are actually extraneous solutions. They're extra imposter solutions. Let's take a look at this last example. The absolute value of 3x plus 2 is equal to 4x plus 5. So again, anytime I have an absolute value equation, I need to create two equations. The first is going to be 3x plus 2 is equal to 4x plus 5. Basically just the equation with the absolute value symbols removed. The second equation is going to be 3x plus 2 is equal to the opposite of 4x plus 5, which is negative 4x minus 5. Make both things opposite. Let's go ahead and solve each of these for x. Subtract 3x from both sides, and I get 2 equals x plus 5. Subtract 5, and I end up getting that x equals negative 3. The second equation, I'll subtract 3x from both sides again, and get 2 equals negative 7x minus 5. Add 5 to solve for x. 7 equals negative 7x. Divide both sides by negative 7, and x equals negative 1. So these are the two solutions. In order to figure out if one is an extraneous solution, I'm going to go ahead and check my answers. Here's my work where I plugged in negative 3 and negative 1 for x. On the left side, you can see that when I checked x equals negative 3, I got the statement that the absolute value of negative 7 is equal to negative 7. That's not true, because the absolute value of negative 7 is 7, which is not equal to negative 7. So x equals negative 3 is not a solution. When I plugged in negative 1, I got a true statement. Please pause the video right now to try this example on your paper. This is the first problem from your homework assignment. Once everybody's ready to check their work, please press play to check your answers with mine. Here's my work where I solved for x. I created my two equations, the first of which I set the inside 3x minus 2 equal to negative x plus 6. In my second equation, I kept the inside the same and changed negative x plus 6 to its opposite, x minus 6. I made negative x opposite to get positive x, and positive 6 opposite to get negative x. You can see my work here where I solved for x in each equation. I got the answer x equals 2 and x equals negative 2. Now to check to see if either of these are considered extraneous solutions. Extraneous solutions, remember, are solutions that appear to be solutions but are really just extra and not actually solutions to the equation. So I plugged in x equals 2 to see if it was in fact a solution. You can see from my simplified work that I got 4 equals 4, which tells me that x equals 2 is in fact a solution. I then plugged in x equals negative 2 for x, and you can see that I got the simplified statement 8 equals 8, which is a true statement, so x equals negative 2 is also a solution. Neither solutions are extraneous and are both considered part of the solution set.